Okay, so hi guys. So in this video, what I want to do is another trig substitution video, and this time I'm not going to look at any notes. So hopefully I can do this without looking at any notes. The only thing I will look at though is going to be the formula, because obviously I don't have it memorized. So give me 1 second, guys. Okay, so for this one, we're gonna use u equals a sine theta, just like the last problem that we did. And sorry guys, I'm connecting my... Okay, so we're going to use u equals a sine theta, and we know from this problem that a, if you look here, so we can rewrite this, and this can be 1 over, so the integral of 1 over the quantity x squared, or actually, hold on, x to the 4th square root of 9 minus the quantity x squared. Or actually, maybe it is... Hold on, guys. I'm looking. Here. Okay. So actually, no, yeah, it is. It's gonna be u equals a sine theta, so it's gonna be... So here we have u to the 4th square root of 9 minus u squared, and the thing is, so... Oh my, this one's weird. Okay, so... we're gonna make u equal a sine theta, okay? So basically, I'm just gonna rewrite this. I'm gonna write this as x, as in terms of x, a squared minus x squared, where a is greater than 0, then x will be a sine theta. So here I'm going to say this is x to the 4th square root of 9 minus x squared. So here we're going to have... So obviously we can rewrite this, and we can rewrite this as the integral of 1 divided by, and it's going to be x raised to the 4th power minus, times the square root of the quantity 3 squared minus the quantity x squared. Okay. So, and then it's going to be dx. So here dx, right? Sometimes you'll see it written as like dx over x to the 4th square root of, like when they write it, you would see it as dx over x to the 4th square root of 9 minus x squared. It's the same thing. It just means that they put the dx on the top fraction. But it's the same thing. This is like saying, you know, it's like if I say the integral of 1 over u du, that's literally just equal to like the integral of 1 times du over u, which is literally just the integral of du over u. But it's the same thing. They're the same thing. Okay, so don't let that confuse you. But if it helps, you can write it this way if it helps. Like if they give it to you this way, you can always rewrite it this way, if that helps. So, let's see here. We're going to use, so obviously we know that because because a is greater than 0, and because we have the integral, or the square root of the form a squared minus x squared, then we know that u is equal to a sine theta. And we already said that a is equal to 3. And we said that we know that u equals x, right? So u equals x. That's literally what we put right here and right here, okay? Now, that means that we're going to have u, or rather, we can say u equals x, so we can say x. So we're not really going to put u, we're going to put x, right? So, in reality, it would be better to use x in this case. Like anytime they give you like u equals a sine theta, instead use x equals a sine theta, or whatever they give you for your for u. What if they give you like u equals something, then put whatever u equals to into the so here, for example, I'm going to say u is equal to 3 sine theta. So then that means that because u equals x, x is equal to 3 sine theta. Okay, right? I know that. Okay, so then we know that if we divide both sides by 3, sine theta is x over 3. We know that, right? However, we want to know what, so we know that x equals 3 sine theta. We know that. We can substitute, and we can find, or actually we can do x equals 3 sine theta, and we can find the derivative of x, dx, which is going to be 3 cosine theta d theta, because it's with respect to theta, right? So then we're going to have the integral, the following integral. We have, so dx is 3 cosine theta d theta over, and and we know that x equals 3 sine theta. So if we rewrite it, x to the 4th square root of 9 minus x squared, x squared. So we can rewrite this as the following: the integral of 3 cosine theta over, and it's going to be d theta, over, and it's going to be 3 sine theta, so it's going to be 3 sine theta, and it's going to be raised to the 4th power times the square root of 9 minus the quantity 3 sine theta squared, right? So it's going to be like this, and then you have, so this is going to be the integral of 3 cosine theta over, and 3 to the 4th, that's going to be, I believe that's 9 squared if I'm correct. Yes, that's going to be 81 sine to the 4th of theta times the square root of 9 minus 9 sine squared theta, d theta, right? Now we can write, we can take 3 over 81 out, of the integral, and we can do cosine theta over sine to the fourth of theta times the square root. And we can rewrite this. We can factor out a 9. So 9 times 1 minus sine squared theta. And then this is d theta. So then we have 3 over 81. That's going to be... oh, how much is that? Is it going to be 1 over 27? I think. Give me a second, guys. Yes, 1 over 27. So it's going to be 1 over 27 times the integral of cosine theta over sine to the fourth of theta. And then we're going to do times 9. And we know that, so basically we know this part, hold on. This part here is going to be rewritten as cosine squared theta, and then we're going to do d theta. Okay, so this part is this one. Anything that I highlight with the same color, that's what it turned into. Like 1 minus sine squared theta is cosine squared theta. Okay. So we have 1 over 27 times the integral of cosine theta over, and we have sine to the fourth of theta times the square root of 9 times the square root of cosine squared theta, d theta. I mean, we can, okay, so we can, I believe we can, split, so we can split cosine theta over sine to the fourth of theta into, using trig identities, we can simplify that. So let's see here, 1 over 27 times the integral of cosine theta over sine theta times, and okay, so it's going to be times 1 over sine cubed theta, and then it's going to be times 1 over the square root of 9 times the square root of cosine squared theta, which is really the absolute value of cosine theta, and then d theta. So then we have 1 over 27 times the integral of cotangent theta, cosecant cubed theta, times, so 1 over 3 cosine theta, it's going to be times 3, hold on, it's going to be times, if I say 1 over 3 cosine theta, or 1 over 3 cosine theta like this, 1 over u cosine theta, that's going to be 1 over u times 1 over cosine theta, which is going to be secant theta over u. So really this is going to be secant theta over 3 d theta. Oh my goodness. So then we have 1 over 27 integral, and we're going to do cosine theta over sine theta times 1 over sine cubed theta times the, so it's going to be times 1/3 times the cosine theta over sine theta, all of this d theta. So then you're going to simplify this. It's going to be, so we have 1/3, we're going to take the 1/3 out because it's a constant, times 1 over 27 times the integral of the, so it's going to be cosine theta over sine theta. And we're going to go ahead and, wait a minute, hold on. Times, did I do that right? Hold on. It's times 1/3, so it's 1/3. And then times 1 over cosine theta. My bad. This part is 1 over cosine theta, because remember I said over here that 1 over 3 cosine theta is 1 over 3 times 1 over cosine theta. Okay, so my bad. And it's going to be, so it's going to be 1/3 times 1 over 27 times cosine theta over sine theta, or times the integral of cosine theta over sine theta, times 1 over sine cubed theta. So let me just do it this way. I'm going to bring the 1 over cosine theta over here, so that way I can just go ahead and cancel it out right away. And then the 1/3 is already on the outside, so we're just going to put d theta. So this simplifies to 1 over 81, and then times the integral, and then we're going to have, so the cosine theta cancels out, and we have over 1 over, or times 1 over sine to the 4th of theta, d theta. Now, if we look at, let's see, hold on. So, we can use, okay, so we can use trig identities to integrate this. 1 over 81 integral of cosecant to the 4th of theta, d theta. Now, the way that they do this is what they do. So here, so we're going to split this into, so cosine to the 4th of theta, or cosecant to the 4th of theta, is equal to cosecant squared theta times cosecant squared theta. So cosecant, so we can say that this is equal to cosecant squared theta times cosecant squared theta d theta. And this one, we know that, so basically cosecant squared theta is going to be equal to 1 over sine squared theta. And we know that that cotangent squared theta plus 1 equals cosecant squared theta, right? So we can rewrite that over here, 1 over 81 times the integral of cotangent squared theta plus 1, and then times cosecant squared theta d theta. Okay, so this is what it's rewritten as, the cosecant squared theta. So then we're going to go ahead and use U substitution to what is it called? So we're gonna substitute, and let me see. Give me 1 second, guys. It's been a while since I've done this, so I do apologize. Because I don't quite remember my. Let's see. Hold on. Okay, so I got it. So, okay. so we can use u substitution. U can be equal to cotangent squared theta. Now the derivative of u with respect to theta is going to be negative cosecant squared theta d theta. Now, this will give us 1 over 81 times the integral, and we're going to plug in u for cotangent squared theta. So we have u, and actually my bad, u equals cotangent theta. So that means we're going to have u squared plus 1, and then we're going to have times negative du, because if you think about it, that's what cosecant squared theta d theta equals to. Negative du equals cosecant squared theta d theta. So then we're going to take out the negative. We're going to get negative 1 over 81 times the integral of u squared plus 1 du. So then we go ahead and simplify this using power rule. Remember that the integral of u to the n equals u to the n plus 1 over n plus 1, such that n does not equal negative 1. Okay? So then we have negative 1 over 81 times the integral, and actually we're going to do u cubed over 3 because it's going to be u to the 2 plus 1. So it's u to the 2 plus 1 over 2 plus 1. And then plus u to the 0 plus 1 over 0 plus 1. Right? So then we have negative 1 over 81. And then we have times, and then we're going to do u cubed over 3 plus u. So then this will give us negative 1 over 81 times, and we can substitute u back in. U was equal to cotangent theta. So you have cotangent, not cosine, cotangent theta cubed over 3 plus cotangent theta. So then we have negative 1 over 81 times 1/3 cotangent cube theta, and then it's going to be minus 1 over 81 times cotangent theta, like this. And then we have negative 1 over 243 times the cotangent cube theta minus 1 over 81 cotangent theta. So then we can factor out, and we can, or actually, so what we can do is so basically, this is going to be the integral plus c, but remember what we were doing at the very beginning of this video? We were not integrating with a trig function. We were integrating with an algebraic function, or an algebraic term. So, this will actually be, so we need to write this in terms of, in algebraic terms. Now we know that sine theta was equal to, and I believe, let me go ahead and check. It was equal to x over 3. So we know that sine theta is x over 3. So we can use right triangle trigonometry and let me just try to draw a right triangle very quickly, if I can. And then, okay. So here, this is our right angle, obviously. And this is theta, and we know that sine theta is x over 3, so it's going to be opposite over hypotenuse. So we can find the third side using Pythagorean theorem. X squared plus b squared equals 3 squared. So then x squared plus b squared equals 9. So then that means that b is equal to the square root of 9 minus x squared. So cotangent theta is going to be equal to, it's going to be not opposite over adjacent, but adjacent over opposite. Let's see. So what is it called? Adjacent over opposite, right? Now, that means it's going to be the square root of 9 minus x squared over x. Okay, so, so then our integral is going to be the following. Negative 1 over 243, or our antiderivative, negative 1 over 243 times the square root of 9 minus x squared over x. And actually, let me do it this way. So we have negative cotangent cubed of theta over 243 minus cotangent theta over 81 plus c. So then we're going to have negative the quantity, and we know that cotangent theta is 9 minus x squared over x, or square root of 9 minus x squared over x. So we have square root of 9 minus x squared over x, right? And then this is going to be cubed over 243 minus the square root of 9 minus x squared over x over 81 plus c, plus the constant of integration. Now, this can be negative, and it's going to be the square root of 9 minus x squared times the square root of 9 minus x squared over 243, or sorry, over x cubed, my bad, over 243. Let me make these bigger, this one, minus the square root of 9 minus x squared over x over 81 plus the constant of integration c. So this simplifies to so it's going to be negative the quantity 9 minus x squared times the square root of 9 minus x squared over 243, and then minus the square root of 9 minus x squared over x divided by 81 plus c. Okay. So then this gives us, and we can simplify this in terms of like exponential rules. So we can say that this is equal to negative the quantity 9 minus x squared times 9 minus x squared raised to the 1/2 power. So basically, we can do this rule here. Hold on. Right. And then this is over 243, and then minus, and then we have the square root of 9 minus x squared over x times 1 over 81 plus c. So then we can use the laws of exponents. So we can say that this is equal to negative, and it's going to be negative 9 minus x squared raised to the, and 1/2 plus 1, that's 3/2, right? Over 243, and then minus 9 minus x squared raised to the 1/2 over x power, or actually it's going to be, and because it's 1 over times 1 over 81, so it's going to be over 81x, and then plus c. At least I think that's how it is. I hope. Let me go ahead and check it very quickly. Oh, and my bad, guys. Hold on. I forgot to do something. So, in this part here, it's supposed to be times, and it's supposed to be, let's see. So, okay. It's supposed to be over 243 x cubed. So yes. And you can rewrite this as the following as well. So you can say that this is negative the quantity 9 minus x squared raised to the 3/2 power minus the square root of 9 minus x squared over 81x, and this can be over 243 x cubed plus c. This is another way you can write it. So, yeah. So that's how you do this one. Oh my goodness, this one was a really long one. So yeah, I hope that helps, guys. If anybody has any questions about this, let me know. Yeah, if anybody has any questions about this, please let me know. Please like, comment, and or subscribe. And with that being said, guys, thank you so much for watching. If you watched all the way through, these problems are very painful. They're very difficult. So if you don't understand it right away, it's okay, because they're very hard. So with that being said, guys, thank you so much for watching, and I will see you guys in the next video. Bye, guys.